It's not even on. Is it on, sir?
Yeah.
It is. There's like.
I'm not gonna use all of it, obviously, part of it.
Oh my gosh, Ash, shut.
Oh, I just want to hi. No.
Hi, welcome to Engineering Club. I have my very smart, talented student here. We're going to go through their design and engineering. Right, who's going to start?
Oh yeah, I'll start. So we've designed a thermoelectric water bottle with two chambers, one of them with hot water and one of them with cold water. It's powered by a thermoelectric Peltier device, which produces cold on this side and heat on this side. We're going to put 1 amp at 4 volts through it, which should be sufficient, and it's about the same rate your phone charger will put through your phone, and then so.
The way we're going to set it up is we're going to have 2 bottles and put them together like this with a heatsink in the middle. We're going to put the Peltier device between wood, because wood is an insulator and we don't want any of the heat to escape.
In order to power the Peltier device, we'll be using solar panel, and yeah, that will heat up the PSU.
So effectively a heatsink is a series of metal prongs attached to the Peltier plate, which will help to transfer the heat or cold coof energy faster throughout the liquid. We're making ours out of copper because it's one of the best transfer.
Why don't you just buy the heatsink from the market?
Because the ones on the market, the prongs aren't long enough for what we want to do, so they don't transfer the heat as fast as we would like it to.
Excellent. Thank you.
Should I say like
Anything you like.
Okay.
No, you don't say hello in the middle of the video. Hello for the future. Okay, so they have formed this wood with the exact shape of the bottle, so it will fit in nicely. To place the Peltier plate in the middle, they made a hole, and they have these 2 holes here, as you can see, for the wires. There are gaps, obviously, between the Peltier plate and the wood. What are you going to do with those gaps?
We're going to fill them with a silicone glue type thing, which won't let any water through to the other side or in the bottle, like outside of the bottle.
Excellent.
And
are you going to cover the wood as well, to just so won't have it affected by the water?
yes, we are.
Brilliant. And tell us about these heat sinks. It looks so nice and
Yeah, it's so pretty.
stylish.
All of the heat sinks online weren't good. The prongs were too small, so we decided to try this design out. We're not sure.
Yeah, we're not sure. We're trying, see if this works or not. If it didn't, we'll change the design. So this base here, we're gonna use the thermal glue to stick our heatsink like this to a Peltier plate, and the whole thing will go inside like this. Obviously, we have the other one, the heatsink, and the bottle goes there. With the gaps, there's one connected to our solar cell. We just need a switch. Seal all these with silicone, and hopefully it will work. We just fill it with water and turn it on. We have tested, obviously, the Peltier plate, it works, and not 100% sure with the heatsink. I will try. It's new invention. Yeah, you're gonna be rich. Then I can quit my job. Full-time YouTuber. ready?
Hello guys, this is our experiment on how we have
Step out.
coincidence.
Where have you been all this time? Football club.
You're gonna shoot me, man.
You know, I'm going to put you on the video. Okay, go on.
Bloopers?
So who is coming? Who is talking? Are you part as well?
We need
Yeah,
someone to
but
talk.
I'm gonna decide at the moment.
Okay, go on.
Okay.
Right.
So basically, this is our finished water bottle at the moment. Last week we sealed it off with some thermal glue so that there weren't any leaks. Well, as little as we could possibly make it. Yeah.
And we've connected it up into a circuit with one end of the Peltier device connected onto a switch, which you press down to turn on, and you expect the current to go through this, come back, and go around and heat one side and make another side cooler. We'll detect the temperature using an infrared thermometer, and the way you do that is,
Or we can just have this open and measure it with the
yeah.
classic thermometer.
Thank you for
So this is our innovative product, ready to be tested. Don't forget, this is just a prototype, and I don't know if it's gonna work well or not, and if it's efficient or not. Right, we have tap water in here now, and I'm just gonna measure the temperature before we connect it to the power pack. So it's gonna make it visible for you too. .1, if you can see. Let's check the other side too. .3. So yeah, they're almost same temperature. Now I'm gonna connect it. So here is our source of electricity connected. As we know, water has high specific heat capacity, means it would take longer to take the energy and warm up. So I'm just going to leave it for a while and then come back and measure the temperature. It's a bit leaking. I think it's not sealed very well, or maybe it's from the caps. I blame my students for that. Yeah, it is from the caps. Here is fine. So, well, sure. Next time we make it better. So let's measure the temperature, see if we notice any changes or not. Hopefully there is. So first, cold one. .2. Wow, that's great. So it's gone down by 5 degrees Celsius. Can you see this? Now the hot part, 34.4. That is amazing. I mean, it's not perfect, but we do have almost double the temperature on the heat side here. Wow, I can feel it's warm as well, and here is cold. I doubt it if it will remain like this, unless you have very efficient heatsink. But this is great. This is perfect temperature for summertime, and this might not be good for making a cup of tea, but definitely is warm water. So let's measure it again. 34. So as I did expect, it's gone up 17. Yes, the heat sinks are not perfect, but it works. I can disconnect it now when I get to the lowest temperature and use it as it is. So well done to all my students and a little bit myself. It works. Thank you for watching. And I have a question. Definitely we can improve this design. If you write in the comment section that what changes we should do to this design to make it more efficient and works better. It could be number of Peltier plates, it could be heatsink, it could be even having these two bottles next to each other. I don't know, because currently if we take the router out and the heatsink would be out of the router, I don't think it would be very effective. So let me know what you think, and if anyone wants to steal our design, good luck, we don't mind. It's gonna be a cool project for STEM competitions and school science fairs. So yeah, thank you.